Hello everyone, welcome back or wherever you are. Yeah, so it's kind of unexpected that we're gonna have this extended e-learning today. But you know what, we're just gonna do our best and do what we've been doing before, that is do the math. So for next, let's see, 4 more days of B days, I am going to do 2 lessons. First 2 lessons will be skill 38, verifying trigonometry identity. And the last 2 lessons will be skill 39, solving complicated trigonometry equations. Alright, at home, if you have a printer, you're more than welcome to print out filled out notes or the blank notes and then kind of go along with it as I'm teaching. Or if you're like me, where you haven't used the home printer for years, yeah. Don't worry, all you need is just a blank piece of paper and a pencil and a calculator. So once again, you will need a calculator for the lesson, although today and tomorrow you won't need it, but last 2 lessons you will. So just, yeah, have your brain ready to go. I know some of you will just be very tempted to skip through it and just copy down the answer for your notes and try to use that to do your IP. Well, guess what? It's not going to work. So please, I know I'm not going to make it too long of a video. Just watch it and then just follow along with me. Yeah, one more thing. Don't do math with your eyes. In other words, you can't just look at what I'm doing and trying to do it. That's not going to work. So please, please, please write it on a piece of paper so you can remember. All right, enough with that introduction. Let's go. Skill 38 is verifying trigonometric identity. So in order for us to do that, I'm kind of going to skip some of, parts of the notes. So just follow along with me. We have to remember what we did on Thursday, the last class that you had with me. That is, we learned 4 of the trig identity that we already knew are. So what were those 4? Let's see. Cosecant of theta is, cosecant is reciprocal of sine, so 1 over sine theta. Secant of theta is equal to, secant is a reciprocal of cosine, 1 over cosine theta. Tangent theta was going to be sine theta over cosine theta, and cotangent theta is going to be cosine theta over sine theta. That's just a review of what we've been doing before. You also learned 3 more trig identity, which are pretty important. They're also called Pythagorean identity, trig identity. The first one was sine square theta plus cosine square theta is equal to 1. Second one, 1 plus tangent square theta is equal to secant square theta. Last but not least, 1 plus cotangent square theta is equal to cosecant square theta. These 3 we must memorize that. Okay, because we're also going to use those trig identity to do the bottom problems. So as the title suggests, all your problems will look something like this, where there's an equal sign and you have 2 expressions going on. So that is equal to that, that is equal to that, and lovely problems at the back as well. So what is our game plan? Here is what we're going to do. In order for us to verify that these 2 are the same expression, you have choices. You can choose from the one side, do all the magic, and end on the other side. Or you can work separately from 2 different sides and get to the same answer, and that is enough to verify that 2 expressions are equivalent. I'll explain you more once we get to the real problem in a second. So in order for us to do that, a few things to keep in mind. Number 1, always start with the complicated side. What do you mean by that? So more terms there are, something that looks more complicated. So for example, over here, there are 2 terms on the left side, so I'll probably start over left side on that problem. Look over here, I'll probably start from the left side as well. Look at the back. Which side looks more complicated, left or right? Left, yes. Over here, left. Over here, left. Well, it looks like all the problems you just start from the left side. It is okay to start from the right side, but you get stuck a lot of times. For example, this one, like if you start with the tangent theta, what are you going to do? Like, how are we going to go from here to there? Like, kind of impossible. So always start with the complicated side. What else do we need to do? We also need to, well, it's kind of similar to what we did on Thursday, where if you can use trig identity, use it. So what do I mean by that? If you see something like sine squared plus cosine squared somewhere, instead of that, use 1. If you have secant squared theta minus 1, substitute that with the tangent squared theta. Remember all the variations we learn as well. So use those. So keep those eyes up there. And once you use a trig identity and you can't use anything, rewrite everything in terms of sine and cosine and work your way out. Okay? Alright, so let's go. We're going to do the problem on the left side. Secant theta minus cosine theta is equal to sine theta times tangent theta. Start with the complicated side, the left side. So I'm going to move the... Please remember the goal. You start here, do all the magic, and we want to end on the right side of the equal sign. So let's start. Is there any trig identity we can use? No, none of those has a square in it, so I probably can't use any of those 3 trig identity. That means let's go ahead and rewrite everything in terms of sine and cosine. Secant is a reciprocal of the cosine, so I get 1 over cosine theta minus cosine theta is a cosine theta, so cosine theta. We have a fraction minus the integer, so what are we going to do? Probably make it cosine theta over 1. Subtracting fraction, we need a common denominator. So what's a common denominator between cosine theta and 1? It's going to be cosine theta, so I'm going to multiply cosine theta top and bottom of the second fraction. Then what do we get? We get 1 over cosine theta minus cosine theta times cosine theta is cosine square theta. And please remember, for the trig ratio, you put the square over there, over cosine theta. Good so far? Alright, we have a common denominator, so I'm going to combine those 2 fractions as a denominator of cosine of theta. Your numerator becomes 1 minus cosine squared theta. Okay, a lot of you are probably going to be like, I'm kind of stuck. What am I going to do here? Because it's not like I can do something. Well, that's probably where you need to kind of be suspicious and think, is there any trig identity we can use? All right, look at your numerator. I have 1 minus cosine squared theta. Which one has 1 as cosine theta squared? The first one. So you need to think about, is there any way that I can change the first trig identity so that it becomes 1 minus cosine squared theta? Yes, there is. What am I going to do? Well, what if I move that plus cosine squared theta to the other side of the equal sign by subtracting cosine squared theta from both sides? So let me write it here. So we have sine squared theta plus cosine squared theta is equal to 1. I'm going to subtract cosine squared theta from both sides and see what happened. I get sine squared theta is equal to 1 minus cosine squared theta. So instead of 1 minus cosine squared theta, I'm going to use sine squared theta. Look over here. So instead of that, I'm writing sine squared theta over cosine theta. Everyone good so far? Okay, and then you're like, well, that doesn't still help me, Miss Major, because I need to go from here to here. That is our destination. I need to get to sine and tangent. What am I going to do? Well, that's where you need to just stop and think a little bit. Alright guys, notice that my final answer, I want to have a sine by itself. Right now I have a sine squared theta. What I'm going to do over here is I'm going to separate sine theta by itself. Then what do I have left on the numerator? I have another sine theta left on the numerator divided by cosine of theta. Right? Because they're still the same expression. Miss Major, can you explain why you did that again? Sure, because I want to get to sine times tangent as my final destination. That means I need to have a sine by itself, so I just kind of separated here by itself, left with sine theta times cosine theta. Alright, now we're almost there. Alright, so sine theta times, what do you know about sine over cosine? Sine over cosine is the tangent theta, so I put tangent theta, and guys, Did we get to the final destination that we wanted to get to? Yes, we did. So you put check mark and done. Cool? Alright, so that's how we do it. How to verify, review one more time. Start with the complicated side. Do all the magic. All the magic includes use trig identity if you can. Rewrite everything in terms of sine and cosine. Sometimes you need to pause it and think, like this problem. And then get to the other side of the equal sign. Okay, alright, we're going to do one more problem on the right side. By looking at it, I probably would like to start on the side. Probably doesn't really matter. Left side. Because there are more factors to it. There are 3 things multiplied, there are 2 things multiplied here. So let's go over here. Is there a trig identity we can use? No, none of them is square in it. So go ahead and rewrite everything in terms of sine and cosine. Cosine theta divided by sine theta times cotangent theta is cosine theta over sine theta. Equal to, let's see, look at your denominator, the big fraction. Notice that sine theta divided by sine theta that I can cancel out. Then I'm left with cosine theta divided by cosine theta. Alright. You should be like, I'd like to cancel it and I get the answer of 1. Right? Yes, you can, but what I would like to do here is probably I'm just going to stop for a second and think about one more time. Where do I want to get to? I want to get to secant theta times cosine theta. Do you see you already have cosine theta there? So I'm going to separate that. So cosine theta times 1 over cosine theta. Because that's the denominator, so I can separate it like that. Now see what happened. Cosine theta times what is 1 over cosine theta? Secant theta. Notice you just got to the other side of the equal sign. Done. What just happened? All right. So that's one way you can do it. You could have done it the other way. That is, you can work it out something on the left side to get to something. You can work it out on the right side to get to something. And if both somethings are the same, that is enough for you to verify. So let me just show you. Left side, I'm going to do what I did over there. So I have cosine theta over sine theta times cosine theta over sine theta. Blah, 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 blah. I got to cosine over cosine, which is equal to 1. Or you can just say right side and do secant theta times cosine theta equal to secant theta is 1 over cosine theta times cosine theta, which is going to be cosine theta over cosine theta, that is equal to 1. And you conclude that since 1 is equal to 1, I verified. So you can do that way as well. Alright, so I just did 2 problems. That should be enough for you to kind of get it started. You just need to do a lot of more problems to it. So for those who have notes, you can go to the next page. For those who don't have notes, just do it with me. Now we're going to do this problem. So for those who are doing it on a piece of paper, write this down. Secant theta times cosecant theta minus blah 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 equal to tangent theta. That's going to be the last problem I'm going to do. Maybe. Start with the complicated side. I'm probably going to start with the left side. There are lots of terms there. And then ends with the tangent theta. Any trig identity we can use? No. So rewrite everything in terms of sine and cosine. Secant is 1 over cosine theta times cosecant is 1 over sine theta minus cotangent is cosine theta over sine theta times cosine theta. Equal to, let's see, let's clean up a little bit. Inside of the parentheses, 1 over sine theta minus that same as cosine theta over 1, so I can multiply numerators together. Cosine theta times cosine theta is cosine squared theta over sine theta times 1 is sine theta. Notice inside of the parentheses, both of your fractions have a same denominator, that is sine theta, so I can combine it because you're adding and subtracting. So my numerator becomes 1 minus cosine squared theta. Alright, pause and think. what am I doing here? What else can I do? And for those who have sharp eyes, you probably recognize 1 minus cosine squared. Why am I recognizing that? Because 1 minus cosine squared theta comes from the very first trig identity. So 1 minus cosine squared theta is equal to sine squared theta. Didn't we use that over here? Yes, we did. So we're going to use that again to get 1 over cosine theta times 1 minus cosine theta is sine squared theta according to the trig identity. So I just use that. And now let's simplify it. Over here you have a sine squared theta divided by sine theta. So one of sine cancel out. We're left with sine theta over cosine theta. What is sine theta over cosine theta? Tangent theta. Notice that's, oops, sorry. That's your final destination. Check. Okay. All right. I need you to pause your video and I need you to try this problem. Yeah. Sure. Try that problem and resume the video when you want to check the key. Well, all right. So let's check it together. Hopefully you guys got it. It was a little bit confusing, but oh well. I'm going to start from the left side as both are fraction and it seems pretty complicated. Trig identity, no I can't. Rewrite everything in terms of sine and cosine. So sine of theta over cosecant theta is 1 over sine theta plus cosine theta over secant is 1 over cosine theta. Please do one fraction at a time. So this is sine theta divided by 1 over sine theta. When you're dividing by fraction, that's same as multiply by reciprocal. So that multiply by, what's the reciprocal of 1 over sine theta? Sine theta over 1. So I get sine theta times sine theta. Plus, same thing over here. Cosine theta divided by 1 over cosine theta multiplied by reciprocal. I get times by cosine theta. So I get sine squared theta plus cosine squared theta. When you get there, everyone's like, woo, 1. And then you're probably like, what? Is that where we want to get to? No, we want to get to secant squared theta minus tangent squared theta. Then what are we going to do? There are two ways you can do it. I think this is the easy way of doing it. That is, just stop there. So that was the left side. And go ahead and visit your right side of secant squared theta minus tangent squared theta and work from there and get to 1 as a final answer. Alright, secant squared theta minus tangent squared theta, what do you know? Secant squared theta minus, so you move that tangent squared theta to the other side of the equal sign, get to 1. That was one of the variation of the trig identity, so that becomes 1. Notice left side becomes the same right side. Done. So that was pretty easy. Okay, I'm gonna conclude lesson here. If you're more than welcome to try those 2 problems here and check the key with the filled out notes on my haiku. If not, that is the end of today's lesson. What will be your IP? On my haiku, I uploaded skill 38 IP. Your homework is to do number 1 through, I don't really remember, what was it? Number 1 through something, number 1 through 4. Okay, so try, oh, can you see it? Try number 1 through 4. These 4 problems, you're more than welcome to pause this video and then have work those problems out, write it on a blank sheet of paper and then do it. That might save your time, or you can go ahead and then download your IP and go from there. IP procedures stay the same. You're supposed to show all the work and everything. Once you're done with that number 1 through 4, you're going to take a picture of this IP using your cell phone. Everyone has cell phone. You can use your tablet. I don't care. And on my haiku, there is a link that you can submit skill 38 number 1 through 4 problems. So click that link. It's going to be a Google form. Fill out all the information and upload that file of your completed homework number 1 through 4 there. And that will be your homework for today. which is March 17th, Tuesday. Okay, so this Thursday, this Thursday we're gonna start the second part of skill 38 and finish that lesson. All right, I hope this video helps you. If you have any questions, please feel free to let me know, email me, or come to my virtual office hour. All right, guys, have a good one and see you soon.